Welcome back to Beanland grade 5s to 8s. This week we're going to zoom in on the bean leaves, look at their overall shape, their edges, the veins, and even the types of leaves that are growing now into our third week. Today we are at day 14. That's 2 weeks since we first put the beans in water, and the 2-week mark seems to coincide with a significant landmark, and that is that the cotyledons have shriveled up and in some cases even fallen off. In the two bean plants that I have here, the cotyledons have fallen off and landed in the soil in one of them, and the other, they're still hanging on, but they are brown and shriveled up. So cotyledons are brown, shriveled, and falling off. Which means that the plant must transition completely into making its own food. And as you can see, for these ones that are in soil, they both have broad leaves, though they are slightly different. One of the plants seems to have a little bit of damage on the leaves, and they are a little bit more curled, whereas the other plant has nice broad leaves that come to a point on either end. They look a lot like spades, although green instead of black. Of all the leaf shapes pictured in this diagram, the one in the upper right, the cordate, probably most resembles our bean leaves. Notice also that the plant is not settling for just 2 leaves. They do come in pairs on opposite sides, but the plants are also starting to develop the next pair of leaves at the node. The node is where all the magic happens. It's where the first 2 leaves have branched off, and there are what's called axillary buds that are right inside of it at the node, and also coming up, the shoot or the stem continues to grow out of that node into the next pair of leaves, so that this plant will be able to make even more food, not just with the first pair of leaves. We can see the second node now at the top of our plant, and possibly some young leaves from it. The space between the 2 nodes of our bean plant is called the internode, and we will monitor how big that space is as more nodes form on our bean plant. The secondary branch, or the lateral branches, have yet to form on our first pair of leaves, but you can expect those to come in soon. They will form at the bud. You should be able to see a small bud inside the first pair of simple leaves. It's time to compare the plants in soil next to the windowsill with the plants that were not in the windowsill. There are 2 important characteristics of the plants that were not in the windowsill. The first is that the leaves are not nearly as big and bushy. They are a little bit more green, but that is only compensating for the fact that the stems are much more pale. The leaves on the other plant are slightly better shape, but again, not nearly as wide and broad as the other ones. One thing that might seem counterintuitive but will make sense is that the stems of the plants that are not in sunlight are actually very tall. They're more than twice the length of the plants that were in the window. Now, why would that be? Why would having less sunlight cause it to grow more? Well, you can think of it like this. The plants are trying to grow to the sunlight. As you can imagine, trees, to get more sunlight, they grow taller so that they get more than other smaller plants. When plants don't get sun, one of the things they try to do is to grow taller to try and find some. So these plants have been doing a couple of things. They've been growing tall, and they also bend toward the window. They've been bending toward the windows, which during the day is big and largely open. They will bend toward the window to try and get some of that sunlight. So that is the main difference. The leaves are not performing as well, but the stems are trying to grow taller to compensate for the lack of light, thinking that they will be able to find some more. Lastly, I need to acknowledge the plant that was in water without soil on the windowsill. Up until a couple of days ago, it had been outperforming the other plants that were in the windowsill until Mr. Austin forgot to water it, and the glass dried up, and with it the roots dried up. And when the roots dry up, the leaves don't get the steady flow of water. But it's a good way to think about the fact that water actually provides structure for the plant. A plant will go limp when it doesn't have water constantly going up from the roots through the stem and out the leaves. Now, this plant might grow some new shoot with leaves up top to replace the ones that have gone limp. That is if the roots can redevelop after they've been dried out and continue to get some more water flowing. As it stands, the stem is still firm enough, which means that there's still some water in it, but it's tough to get it up into the leaves. It might grow some new leaves instead. We will keep an eye on that, but the process of water going up through the roots, through the stem, and into the leaves, and then out the leaves is called transpiration. It's a continuous process, and it actually adds to the structure of the plant. This is why if you leave vegetables in the fridge too long, they go limp, because the water has left it, and the water actually fills out the structures in the plant to make it more rigid, more stable. Today is day 17 for our bean plants. The beans in the soil but not in the sunlight, and the beans that are in water but not soil, have pretty much stayed the same over the last 3 days. They haven't gotten much better, nor have they gotten much worse. So we're going to focus on the plants that are in the sunlight. Now, since the 2-week mark, we've had a little bit of change in these. Notice, first of all, that it's nighttime while I'm recording, and so the leaves have actually tilted down. Now that they're not in the sunlight, they're not going to expend extra energy to keep themselves level to the incoming sunlight. So they actually, at night, they tip down instead of up. And I want to focus today on the leaves themselves and a couple of different features. First of all, the leaf shape. The shape of a bean leaf, generally speaking, comes to a tip. The edges are not, pointed. They're roundish on the other sides. And as I've said before, they look a lot like the spades from a deck of cards. The perimeter of a leaf, the edges, are technically called the margin, and our bean leaves are probably the simplest of all. They are called entire, meaning the entire outside around the leaf is even and smooth throughout. I also want to look at what's called the venation. That is the veins of the leaf. And the veins follow a fairly predictable pattern. If you look closely, you'll also notice that there are some cross sections where the veins are connected as well, a lot like the veins that we have in our bodies. The venation pattern that most closely resembles our bean leaves, I would say, is the top middle, the cross venulate. We've got some small veins connecting the secondary veins on the top of our leaf. Now, the original leaves came in pairs. They came in 2 leaves that opened up at the same time. And we saw those 2 leaves right back at the very beginning of the bean seed. There were 2 starter leaves already in place, just waiting to break out and grow. But now that we have the next node and the next leaves, notice how it is not just a pair of leaves coming out, but what we call a compound leaf. There's 1 primary leaf and then 2 other that are parallel it on the next node. I also want to draw your attention to the fact that there seems to be this layer of fuzz on the surface of the leaf that is quite clear when it is small. Though that fuzz is not just little hairs, they're actually hooks called trichromes. And those trichromes are very interesting because they can actually trap very small insects with their hooks. People have been able to trap bed bugs by putting kidney bean leaves around their beds. The bed bugs, as they walk over them, get trapped by the trichromes and can't go any further. And even our best attempts at trying to reproduce those trichromes synthetically has not been as effective as the bean leaves at trapping bugs. So just to recap our compound leaves, what you'll notice also once the first set of 3 leaves comes out is that the second set of 3 leaves is going to come in as well at different times. When we had the first singular pair of leaves in the beginning, they came out at the same time, but the compound leaves come out 3 at a time at the same node. And we also want to recap the trichromes. Trichromes are not just hairs, they're hooks on the surface of the leaf. and they're single cells, and they can also be sticky. They can trap small bugs even. Like bed bugs. So grow some beans and don't let the bed bugs bite. So while grabbing a bean leaf out of the air may not turn you into a flying raccoon, they may very well keep the bed bugs at bay. Until next week, happy growing.